So as per the problem statement, what information we have for tank number 1? We know the elevation. Okay, so you click on this tank number 1. Then in the data palette, right side window, click on the second tab, that is input. Then click on elevation, which is 2 meters. So for elevation unit also, we have got a big list. Okay, but whatever default meter is there, that is good enough. Then pressure model. Pressure model, there are two options, static pressure and stagnation pressure. So stagnation pressure is equal to static pressure plus velocity head. Right, so more or less those values will be same, but I'll stick to static pressure. Then pressure 1 atmosphere, we don't want to change it. Temperature 15 degrees C, we will not change it. Fluid is water. We'll see later how to change this one in other problems, but here no need to change it.
Sir, just a minute. How to make that input for 1?
Yeah, you need to go to vertical palette, left side, click on the selector, then click on tank number 1. Then click on input, change elevation to 2 meter, pressure model to static pressure. So only two changes you need to do in tank 1. Yes, sir. Yes, Ajay, is it done?
It's done.
Yes, sir, done.
All right. Now let us move to the other tank, tank number 2. So elevation is still 0. Okay, we don't want to change it. Pressure model, we want to be inconsistent with the other tank. And the pressure, since this also is ambient pressure tank, so 1 atmosphere is the correct pressure. So only one changes we did, that is pressure model, we changed to static pressure. Yes, Yakesh, is it done?
Excuse me, sir.
Yes, ma'am.
I think something has gone wrong with my drawings. Can you please help me?
You want to share your screen, please? Yes, ma'am. What happened? Drawing looks okay.
Is this connected, sir?
Yes,
Okay,
you need
thanks,
to.
connected.
Yeah, it is connected, but you need to now click on the selector, left side vertical palette.
The number for here is 1 and 2 in your drawing, minus 2 and 3.
It doesn't matter. Vertical palette, that arrow. Okay, now click on tank 1. All right, so input, you already given that. Okay, go to second tank. So this pressure model should be static pressure, not stagnation. Then click on the bend. So bend elevation is 2 meter.
2 meter.
All right, I'm sharing my screen now. All right, the elevation is 2 meter for that bend.
Yes,
And
sir.
there is this, yes.
Can I share my screen? I just closed up everything and I'm still searching for the vertical palette.
Okay, sure.
Sorry.
Okay, what happened? I can see vertical palette, left side. And that bend doesn't look like a bend. Okay, please click on that arrow selector. All right. So this item number 3, can you just try to drag it little up? It is just to check whether it is connected or not. So it is connected. Okay, put it back. Okay, you can click on the item number 3 and delete it. Control delete, shortcut. First select, then control delete. All right, click on this 2, then delete, control delete. All right, go to junctions. Okay, bend. Okay, select pipe. Okay, to the connection. From 4 to, no, from 4 to 2, sir. There is undo button also, control Z. Once you see that green tick, so that means you are good to go. Okay, click on that arrow selector. Okay, click that open pipe what you have drawn below the second tank. Okay, control delete. All right, so click on first tank. So 2 meter static pressure. Please do the changes. Can maximize that window.
Flap it over.
You can maximize this window, right? And this is hidden here. So I'll just put it on the right side. All right, so click on this. So you are in input 2 meter elevation, and pressure model would be static pressure. Then go to the other tank 2. Elevation is 0, no change there. Pressure model, static pressure. Go to the bend, elevation 2 meter. I am sharing my screen now. All right, so we are at bend. So elevation I already provided. Now if there is a bend, you need to have the pressure drop calculation formula, right? So we have got 4 options. Either we can go for idle check or Miller or crane or SAE. So if I select idle check, then it will use one of the formulas given by idle check. Okay, the idle check also scientist, Miller also scientist, crane also scientist, and SAE is basically 3 scientists put together, right? So let us go ahead with idle check. Then what is the branch angle? As per the piping ISO, it will be say 90 degree. Then R by D ratio. So when R by D ratio is 1, what does it mean? It is short radius bend, correct? And long radius means this R is the radius of the curvature of the pipe or the bend. Okay, so when R becomes more, and for the same D, if the ratio is say 1.5 or 2, it is called as long radius. So long radius will have more delta P or short radius will have more delta P?
Short.
Short radius.
Yeah, short will have more delta P. Any idea why?
A sudden turn, it creates a large surge.
Not surge, but eddies will be formed more as
Yeah.
compared to long radius, and that will kill more pressure. All right, then let's go to the pipe. So you'll select the first pipe, right, and then select the second pipe. So how to select that? Using shift key. You select first pipe, then press shift key, then click on the second pipe. So this way you can input all the data in one book. So on the right side, if you see, the length is default 10 meter. We don't want to change it. Then the geometry, there are three options. Cylindrical means our normal pipe, what we see. Okay, cross-sectional area 5/40 square kind of pipe. Then the second one is rectangular or square. So if your pipe is like a duct with rectangular or square shape, so that pressure drop calculation can also be carried out in FluidFlow. Okay, this is again unique feature of this software. Then the third flow is the geometry is annulus. Like your flow is annular. Like you got a 4-inch pipe and outside pipe is say 8-inch. So if your water or say fluid is flowing through, the space between 8-inch pipe and say 4-inch pipe in the annular space. So that delta P calculations can also be carried out using FluidFlow software. Again, this is the unique feature of this software. It is not available in other software. Then database, use database, yes, nominal size 2-inch. As per our problem statement, it is 2-inch only, 2-inch and 10 meter. Okay, but if I were to change it, then I'll click on this 2-inch, click on these 3 dots. It has got a huge library, okay, to choose from. But here we don't want to change it, so let it be 2-inch and schedule 40. Friction model, we have got 4 options. So if it is water only services, so we use Hazen-Williams, right? If the fluid is other than water, then we'll go for Moody. Moody means Darcy-Weisbach equation, and in that FD, Darcy friction factor. So that will be calculated using Colebrook-White equation or using Moody diagram. Okay, for the different Reynolds number and the Reynolds number and for the different roughness, relative roughness values, it will give the friction factor FD. If you go for Moody equation, Moody diagram. If you don't want to calculate Darcy friction factors, you want to give it as an input, then the third option will come. That is fixed friction factor. And if the fluid is say crude oil or some hot oil, then Shell MIT had developed one equation that will give more accurate pressure drop calculations, right? But if you try to use it for water, it will give a warning in message tab. So in this case, Chirag, what equation we should use?
Hazen-Williams.
Hazen-Williams. Okay, why is that?
For it is we are using water here.
Okay, so
For water services, we use Hazen-Williams.
why?
You just told for water services Hazen-Williams.
Yes, but this Mr. Hazen and Mr. Williams, they had done extensive work to calculate pressure drop for across pipe. Okay, for water. The test fluid was water. So water equation that they have got, which is very accurate for water service, right? So like say fire sprinkler system or water supply network or irrigation system. So if we use Hazen-Williams, we are going to get more accurate number, right? Now it has got one input C. So it depends on the pipe MOC. If it is steel pipe, then it should be between 90 to 110. This again will be given by vendor. Vendor will tell that for the pipe. C factor is 90 or 110. We'll take in between number, let's say 100. So we selected Hazen-Williams, then we put 100. Okay, other things we are going to skip, except this properties on flow sheet. Instead of hide, we'll make it show. Okay, alignment we'll keep it same bottom, and then properties. So this will actually provide a table like the one you see in HYSYS show table. So that kind of table you should see it. So what input parameters you would require, means you would be interested in. So there is input and result. If you expand input, there will see friction model. It is provided in alphabetic manner, so it should be easy to locate friction model. This is input, and in the results I want, if I expand results, I want the flow rate. So these two numbers I should get it, right? Now if you see this first table, it looks all good. It is not overlapping with the pipe, but the second one, this table is getting overlapped with the pipe, vertical pipe. So what I'll do, I'll click somewhere else and you can click on pipe, and in the input alignment, instead of bottom, I'll select left. So this way we can move it to left, right, or top or bottom position. Okay, so once you are completed till this, please write done. If you need help, please ask.
Friction model, sir. How?
Yes, so you need to first select both the pipes. Then
Okay.
friction model, yeah, friction model you change to Hazen-Williams. Then Hazen-Williams coefficient or C coefficient or C factor, change it to 100. Then properties on flow sheet, instead of hide, make it show. Then in the properties, there are two headings, input and results. You need to expand input, then scroll down, then select friction model. Then again scroll down for the results. You select only the flow rate or flow.
Okay.
So once it is done, everybody please write done.
Then we calculate again.
Yes,
16.5.
yes, that's correct.
Okay.
Anyone who is not getting 16.5? All right. So if you actually see this system in place, like, so 2 meter elevation difference is there, and there are two pipes, 10 meter, 2 inch, okay, connected by 190-degree bend. Then that flow rate, the actual flow rate, will be close to 12 meter cube per hour or close to 16 meter cube per hour. What do you think?
Close to 12.
It will be close to 12 because Hazen-Williams will give you
Accurate answer.
more accurate value as compared to other equations, because Hazen-Williams equation is more accurate for water services. Done?